Okay. All right. So this unit is chemical formulas. Everybody got your periodic tables out? Correct, correct, correct. Okay. One thing I want to point out on your periodic tables, real quick, put this on your periodic table because you're going to need it if you did not do this last section. All right. Who remembers what is the charge of everything in the first column? Plus one, plus one. Make sure and put that above there. All right. Everything in the second column, plus two. We're going to skip these guys from now. We'll come back to them in a minute. All right. Everything in the third column, plus three. The fourth column is variable. Most of them do not form ions that often. Tin and lead we'll address a little bit later. All right. Column 5A or 15, what's its charge? -3, good. A lot of you guys had them down. A lot of people in first year did not. Column 6A, -2. And column 7A, -1. And then the noble gases do not form charges. All right. These, bless you, these guys in the middle, they will have variable charges. We're going to address that in our notes today. However, there are three that I want you guys to mark on here that have always charges. Zinc, right here, always +2. You can write it in the upper right-hand corner of zinc. Always +2. Just below it, cadmium, also always +2. Write it on there. It will not be indicated to you. And in fact, if you're writing the name and you indicate it, it's technically wrong. It's like putting an extra comma in. All right. And next to cadmium, right before it, silver, Ag, always +1. Always +1. All right. Those three are always things that will not be given to you, so you'll need to know it. All right. So make sure you have that down. Okay. All right. A couple reminder things, first of all. Okay. Cations are ions with a positive charge. That means they lose electrons. And the anions are the ions with a negative charge, meaning they gain electrons. If you remember this frontwards and backwards, you don't have to rewrite it. But if you're like, oh yeah, I kind of remember it, write it down again. Remember, 7 times to get to your long-term memory. 7 times to long-term. Okay. Which kind of elements form positive charges? Do you guys remember? Well, yeah, cations, but what kind of elements make cations? The what? Remember we had 3 groups of elements. We have metals, nonmetals, and metalloids. Metals make cations. Which ones make anions? Nonmetals, and the metalloids are a little weird. They sometimes do a little of both. All right, so when we are doing this, all right, so this is kind of new stuff, going along with the cations. They are always listed first in a compound that's ionic, and they will write the name as the full name of the metal. Oops, sorry. They will write the name of the metal. So an example like magnesium or barium or whatever, all right? The anions are listed second. The nonmetal suffix is changed to IDE. So for example, chlorine becomes chloride. That indicates it's in a compound. Sulfur, sulfide. And guys, I do give a little bit of grace on this, even on the test. Now hopefully we'll have done this enough by the time the test comes around that we won't have too much of this. But a few of them, like phosphorus, is actually phosphide. We drop the whole suffix. We don't say phosphoride or something like that. And a few of them are kind of weird, like iodine is iodide, and it just looks weird. I mean, some of them just, they don't feel right, but they are, okay? All right, all right, all right. Where'd my scratch paper go? Okay. So on that ending, I do give a little bit of grace as far as spelling. Still see pencils moving? So guys, this is one of those areas, you know, if you are watching this video at home or something like that, if you've got it written down, and you can just kind of scan forward till you get to where the screen changes. Everybody have a good break? Everybody go sledding? Really? Not very many people. Man. I went sledding in my truck accidentally. Scary. All right, are we ready to go on? It sounds like it. All right, so we are going to start with the most basic, or not basic, but what I kind of feel is the simplest compounds to do. All right? We're going to write the formulas for binary ionic compounds. All right, this part is kind of like learning steps in math. The binary ionic are the simplest, then we're going to add the next ones, and the next one's the next one, but it all kind of builds on each other. All right, so when we're talking about things numerically and stuff, what does binary mean? Two, all right? So binary means it's made of only two elements. Ionic means it's going to be made of charged particles, so we'll have to be dealing with the charges, okay? Overall, these types of compounds will be made of a metal and a non-metal. There are a couple of exceptions with hydrogen, but honestly with hydrogen it gets a little weird when it's combined with a hydrogen with another non-metal. It's really covalent, but sometimes they act ionic. It's kind of weird. All right. The overall charge of the compound must be 0 or neutral. Okay, so this is the stuff we started learning when we started looking at the bonding, where we drew the arrows and you had to keep going till you used up all the electrons or filled all the electrons. Now we're going to figure out how to do it without having to draw it all out. Does that make sense? Hopefully. Okay. Overall charge must be 0. And I'll show you, that's one thing we're doing. We're going to learn how to write them, and we'll learn how to double check them. And this is also why, guys, I had to do those element quizzes. We have one more we need to do. We'll probably do it next week, kind of work it in. Just be some easy quiz points, hopefully, to start the semester off. And remember, your grades start totally over this semester. All right, so if you had an A, well, right now you either kind of have an A or you kind of have no grade, because we haven't had any grades, so. Oh. All right. Are you guys ready? Huh? Oh. You guys ready for an example? All right. Let me move these. Okay. Example. Magnesium chloride. Oh, sorry. Magnesium chloride. All right. What is the symbol for magnesium? Mg. Very good. What is chloride is going to be what element? Remember we changed the ending, so what element will it be? Chlorine. What's the symbol for chlorine? Cl. Very good. What's the charge for magnesium? Oh, look at where it's at on the periodic table. It's going to be 2 because it's in the second column. What is the charge for chlorine? -1. Very good. All right. So MgCl, and one thing I want to point out, where did I put my pen? Oh, there it is. All right. When we're writing chlorine or any element whose second letter is L, okay? I know a lot of you guys didn't learn cursive, but the standard way to do it is to write our capital C and then lowercase cursive L, which is kind of a loopy thing. All right, because if I just go C and then a straight line like that, that could be carbon and iodine. Does that make sense? Now, another standard thing I always do, I don't know if this is always standard, but if I'm writing it, if it's I go ahead and put the cap on it and everything. But lowercase l in cursive that was the way I was taught to do it when we're writing it, even when we're not. Capitalization is very, 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 very important in chemistry, right? Because again, and a lot of times I use the carbon ones, capital C, capital O is carbon monoxide, capital C, little o is the element cobalt. So if you're one of those people, and I've seen this more and more lately, where you write all your letters as either big or small capitalized letters, like NA, all right, make sure that little a is much smaller than the capital A, because capitalization is super important when we're writing formulas, okay? All right, now, there is a concept in math called least common multiple. Not least common factor, least common multiple. Least common factor is the smallest number that divides into all of them. Like, if you have 16 and 24, well, 2 goes into both of them, right, when you're factoring things out. But what we're really looking for is the smallest number that they both go into. So 16 and 24, first of all, can 16 divide into 24? Evenly? No. Can 16 can go into 32? Can 24 go into 32? No. Can 16 can go into 48? Can 24 go into 48? Yeah. So the least common multiple of 16 and 24 would be 48. Does that make sense? All right. So when we're using numbers like 2 and 1, what is the smallest number that 2 and 1 both go into? 2. Yeah, it can be one of the numbers. What's 2 divided by 2? 1. So when we write an element with just 1, we don't have to put the 1. 1 is understood. What's 2 divided by 1? And we don't have to worry about the negative. So 2 divided by 1 is 2. Thank you. All right, so C, L, and then we put the little 2 down below like that. Do you guys see that? So MgCl2. Now, we can double check it, because what does the charge have to come out to be? 0. So 1 times positive 2 is positive 2. 2 times negative 1 is negative 2. 2 minus 2 is 0. Okay? All right. Now, let's keep going down. All right, for transition metals, the charge is indicated by a Roman numeral. Okay? Now, if you want to put these Roman numerals on the bottom or back of your periodic table, you can. All right? The Roman numeral for 1, does anybody know what it is? I. Roman numeral for 2, I. Roman numeral for 3, I. Roman numeral for 4, IV. That means 1 before V. And the Roman numeral for 5, V. All right, Roman numeral for 6, VI. And Roman numeral for 7, VII. Now, here's the deal. How many electrons are we trying to get into our valence shell? Do you guys remember? Somebody, did you say it? I thought I heard it. 8, okay? If they have 8, are they going to lose any electrons? No, they're already happy. So the most that anything could possibly lose, and I could be wrong on this, but I don't think so, is 7. I don't think there's anything that's ever going to have a charge more than 7. All right? So that's the only ones you need to know. All right? If you want to keep going, then it's VIII, and then IX, and then X to get to 10. All right? Now, if we have one that looks like this, copper 2 chloride. Okay? And that's how you say the name. You don't say copper II, you say the number. All right. Oh, this question came out last hour. The Roman numerals will always be a positive charge too. You won't ever have Roman numerals for a negative charge. All right, what's the symbol for copper? Who remembers from our quizzes? Cu. I see you. Oh, don't want to be there. That's a bad place. Well, actually, it's a good place if you need to be there, but you don't want to be there. All right, so I just recorded that too. I'm a dork. All right, so copper, what's its charge going to be? 2. It tells you right there, +2. All right, and then chloride is going to be Cl. What's its charge? Oh, I'm so sorry. Oh, sorry. Okay, so copper is +2. Chloride is going to be what? What's its charge always? -1. What did 2 and 1 both go into? 2. 2 divided by 2? 1. And 2 divided by 1? 2. All right. Okay. All right, let's do one. Let's do a tricky one here. Oh, all right. We're going to go off of my notes here just a little bit. Let's go with vanadium, Roman numeral 5, and then we'll go nitride. I don't even know if this is a compound that actually exists, but we're going to say that. Okay, vanadium 5 nitride. Okay, what's the symbol for vanadium? I don't know if we've done that one on our quiz, but if it's got Roman numerals, we know it's going to be in the middle. Anybody find it? V, very good. Vanadium V. All right, and what's its charge? +5. And then nitride, what element's that going to be? What do you think? Nitrogen, yep. All right, and nitrogen charge is going to be what? -3. Okay, least common multiple. We got to find it. Will 3 go into 5? No. Will, so the next thing 5 can go into is 10. Will 3 go into 10? No. Next thing 5 can go to is 15. Could 3 go into 15?
Yes.
Yes. All right, so 15 is our least common multiple. Okay, what's 15 divided by 5? 3. All right, and what's 15 divided by 3? Forget the negative. 5, yeah. And a lot of times they are just that simple where it's kind of the opposite charges, right? But not always, and you got to be really careful. If one will divide into the other one, it should always be in reduced form for the ionic ones. So V3 and 5, okay? And again, I don't even know if this is a real compound. I just made it up using their charges. All right, that makes sense? Now, like I said, back in the day, so copper is +2. It can also be +1. And we had to memorize that if it was +2, you called it cupric with the IC ending. And if it was +1, it was cuprous. Oh, so if it's IC, is it always +2? No, that would have been too easy. So if it was iron, if it was ferric, ic was always the higher charge. And ferric is iron with a +3, and ferrous is iron with a +2. Oh, so they're always 1 apart. No, that would have been nice, because tin has 2 charges, and it went by its Latin name, stannic and stannus, and stannic was +4, and stannus was +2. They were 2 apart. It was just their higher and lower charges. And so you had to memorize all the charges of all the elements. They finally came up with this. It cuts down on errors by using the Roman numerals. But once in a while, you'll still see that. You'll see ferric sulfate or something like that, or ferrous sulfate. All right, it's okay. The better we get at this, then when you start running into those holdovers, the stuff that kind of grandfathered in, it will make sense to you. All right? Okay. Are you guys ready to practice a few on your own? Yep. Okay, what we're going to do, I'm going to give out this worksheet. Now, real quick, we're going to do the first three together. And so if you're watching it at home, you're going to get to see, I'm going to be a minute, I'm going to pass about. We're going to do the first three together, and then you're going to do the next four in your groups together. Does that make sense? All right? And then that's going to be it for today. Tomorrow in class, we'll do the backside. What if there's a snow day? If they call it an AMI day, you'll do the backside. If they don't call it an AMI day, we'll do it on Monday. All right? Okay. So if you're at home, there's going to be a long dead pause.
Good question, Aubrey. I would love to know how this is. I just was thinking how we're on the same road, but like we're both on like the exact same road together. Yes, but like we all publish together.
My guess would be because they provide us.
Yeah, you don't like
You're saying
Like not a lot. There's like there's like 16 inches at my house. Like it's my knees.
What? I checked.
because they don't care about education.
Sure, but like, it's just like you don't want to.
All right, so we'll do the first three together, and then, yes, oh, I think so. All right, guys, when we start doing them when you're doing them, I want you guys to do them in groups of 2 if there are enough people to do groups of 2, or a group of 3 if there's 3 of you at a table. Okay? And I will explain it when I get back up to my decimal area. All right, 3. Okay, now, also, hopefully you're seeing why I had us do the memorizing and do the little quizzes, because it makes it a little easier to figure these puppies out. Okay, so let's look at the first one. Can you guys all see that? So potassium chloride. What is the symbol for potassium? Okay. What's the charge for potassium? +1. Good. What's the symbol for chlorine? C, lowercase l. What's its charge? -1. Hey, this makes it simple. If they are both the same charge, what's +1 and -1 come out to be? 0. That's what we want. So it's just going to be KCl. 1 and 1. That's all it is. Does that make sense? All right, let's look at the next one. Copper 1 oxide. So what's the symbol of copper? Cu. In this case, what's its charge? 1. All right. Oxide, what element's that going to be? Oxygen. What's its symbol? What's its symbol first? O. All right, and it's -2. Good. All right. Okay. What do 2 and 1 both go into? 2. So how many coppers do I need? 2. Cu2. And how many oxygens? 1. Cu2O. Does that make sense? Are you guys seeing how this works?
Yep.
One more. Calcium bromide. What's the symbol for calcium? Ca. And again, see how my handwriting's really bad, so make sure you make your symbols nice. What is this charge for calcium? +2. And then bromide, what element's that going to be? Bromine. What's its symbol? Br. What's its charge? -1. All right, so what do they both go into? 2. How many calciums do I need? 1. And how many bromines? 2. All right, and like that, CaBr2. Okay, so what I want you guys to do, if you're in a pod of 4, okay, and you guys, the people closest to my desk will be the first person. The people on the outside, the closest to the cabinets, will go first. The people on the inside will go second. And what I want you to do is I want you to talk them through it. So whoever's first. So like Brandon, you would go first with Patrick, all right? and you will talk him through barium sulfide just like I talked through this one. And then Patrick will talk through aluminum oxide. If you get stuck, it's okay to ask your partner for help. Or if you see them doing something, say, wait a minute, I think it might be like this. Do not say, hey, you're stupid. That will make me very angry, okay? All right, so go ahead and do that. Go back and forth, and in about 5 minutes, we will check your answers. For those of you at home, email me if you want the answers, okay? Actually, no. For those of you at home, I'm going to keep it running, and then I'll come back and do the answers. All right. And groups of 3, you guys can just work the circle. Oh, yeah. Okay. All right, here, let's go back there. All right. Yeah, try and find it.
Please don't yell at me.
Oh, okay. Yeah, that's trouble. So, make sure you bring it tomorrow. I'll go get some wine. There's one. Oh. Oh yeah, guys, make sure you have your periodic tables. Oh, and tomorrow you'll need those pink sheets too. Or Monday, depending on when we get to it. All right, so let's get it. Hold up. Now, I can kind of tell with that, the S is one of the lines. There's no T. Yes, ma'am. Okay. So what I'll do is I'll do a video like this, and then if we have who's like this, I'll post it and then we'll put it out on all right. I don't think I'm gonna be on today, so I don't think I'll be a video Tuesday. It'll just be a okay. All right. So okay, and if you're traveling, travel safe. All right. How we doing, guys? What time do we get out? Okay. I'm gonna do the answers real quick. If you guys quietly, so that I can record it, you can get your cell phones. I'm gonna record the answers as I do them. Okay. Okay. If anybody wants to help me as we're doing it, barium. What's the symbol for barium? Ba. What's its charge? +2. What's sulfide? S. And what's its charge? So they balance each other out. Whoops. So it's just going to be BAS. Oh, guys, this is the one that a lot of people messed up last hour. Aluminum, what's its charge? +3. And oxygen?
-2.
What did 2 and 3 both go into? What's 6 divided by 3? So Al2, what's 6 divided by 2? O3. A lot of people did that one backward. Okay? Iron is Fe. What's its charge here? +2. Sulfur, -2. They cancel. See you guys. Have a great weekend. Or, I'm sorry, see you tomorrow, hopefully. All right? Go ahead and keep that one because it's just on black and white, so you've got it in case you don't find your other. Okay? All right?
Falling asleep.
And plus 4. S -2. S N S E 2 because they both go into 4. All right? Okay.